今天的会谈呢是准备了5个环节的问题。You can play back. 那么第一个环节呢，我们要先从这个个人背景来问一下 Josh。第一个问题呢是你是如何成为 Rust 项目的一员
？I think the translator may be in the wrong direction. I'm getting credit for the earpiece. Apologies, folks, for the translation difficulties.
How did you end up becoming part of the Rust project?
Thanks. So I've been a software developer for a long time, and I started hearing about Rust really early on when Mozilla was first working on it, and they started blogging about this new language that they were putting together to better handle memory safety and similar. A while later, I started working on a project to work with the Git version control system, and I started looking at libgit2, which was a library written in C, and they had a lot of information that reminded me of what I read about Rust, telling me, okay, this object is borrowed from this other object and you need to not free it, or this object you need to free yourself. And I really didn't want to write that in C. I picked it up as an experiment in writing Rust. So that got me excited about Rust as a user. As a developer, I started working on virtual machines. I had recently written an article on how to do virtual machines from scratch, directly using the KVM technology on Linux, and that helped kickstart some of the movements for things like cross-VM and Firecracker of like lower level VMs than QEMU. And I started trying to recreate that in Rust, and in the course of doing so, I found that Rust missed some key functionality. It couldn't do C-compatible unions. So I started learning about the process to contribute to Rust, figured out the RFC process, and how to make a change to the language to make it possible to better interoperate with C. And after doing that, I'd had so much fun working through that process and had understood the process so well that a couple of folks I was working with said, hey, maybe talk about this at the upcoming RustConf. So I made a presentation at the very first RustConf in Portland, Oregon, talking about how, not just how I added unions to the language, but also how the RFC process worked, how the development process of the language worked. And that process talk went over so well that immediately after that talk, a couple of members of the Rust language team came up and said, hey, would you like to join the Rust language team? We don't have a huge amount of expertise in C interoperability and that kind of low-level detail. We'd like to have somebody who understands that better. I got invited to join, I started getting involved with more things, and everything went from there. Much like Jane's story earlier today, I really credit a huge amount of that to a couple of people at the right time saying, hey, would you like to get more involved? And I'm very thankful for that happening about like 10 years ago now.
Okay. You have extensive experiences in open source projects, from library office to the Linux kernel. How have these experiences influenced your approach to working on the Rust project?
So Rust is definitely the most fun I've ever had working on open source of any kind. I really thoroughly enjoy it, and I credit a huge amount of that to the people that I get to work with. Over decades of working in open source, I've worked on projects at all different levels. I've worked with different types of communities, and at the end of the day, the single most important thing is the community that you're a part of, the people that you're working with, and how that community treats other people and brings more people on board. And Rust, from its very beginning, has been at the forefront of how do we be the leading edge of how to treat people well, get people better included. Other projects are absolutely doing more and more, and Rust just has it as a defining quality that it cares about how to treat people. And this follows with how the project itself is structured. There was a blog post a while back that made the point that rather than having processes that assume that people are perfect, we have processes that assume that people will make mistakes, and we should make our software and our processes more resilient against that. Rust itself is an example of the same thing. Our projects and our governance are done much the same way as our language. Let's not assume people, if everybody were absolutely flawless and never made mistakes, we could write code in any language we want. We make mistakes, we're going to make errors, Rust helps us catch them, and that makes it more fun to write Rust. You can run faster because you've got better guardrails.
OK， 那我们进入第二个环节啊，就 Rust 从 Rust 语言项目的这个管理，然后来了解一下 Rust 项目。王宽成。In your RustConf 2022 opening keynote, you discussed the experimentation standardization cycle. Could you elaborate all this consent and how it guides Rust development?
Sure. So the experimentation and standardization cycle is about how Rust has a very hard stability guarantee. We try never to break anybody who's using older versions of Rust when they upgrade Rust. So this makes us very hesitant to add new features and new items to the library, to this language, and similar, because we will have to support them forever. They're stable. So it makes sense for experimentation to happen outside of the standard library, outside of the language, using macros, using libraries in the Crates.io ecosystem. And so people try experiments, they see what will work. They try a lot of different things in parallel because they're not sure which one will work. And that works really well when they're learning something new. And then later on, once it's clear that there's a clear winner or a couple of clear winners, and this is the right way to do things, the experiment has paid off, it's a good thing, we should do it, then there's a push to try to get that more into Rust, more standardized, figure out how to better support it so that people don't need to go to a third party to get it. And meanwhile, there's this continuous cycle where while we're adding things kind of the last generation of experiments to the standard library, to the language, the next generation of experiments are happening in the ecosystem. And so this is a really close collaboration between Rust and its ecosystem to try to figure out what our next step of development is going to be.
OK， 刚才我问 Josh 的问题是，他在2022年RustConf 有一个开幕演讲，他讨论了实验标准化循环如何促进这个 Rust 发展。这个我刚才这个英语不是很标准，给大家解释一下。Second question, what are the distinctive features of Rust project management model? What roles do the Rust Foundation and the leadership play in the project's development?
So first of all, I think Jane had some excellent discussions of like the fundamental natures of project structure a little earlier today, so I don't want to duplicate that. She covered a lot of the details of how work gets handed out versus work is picked up by people and where things originate, the bottom-up model, that kind of thing. I think the particularly distinctive features, Rust is one of the projects where developers drive a great deal of what's going on all the way up and down the stack. So everywhere from new contributors all the way up to what goes into the language and libraries, all the way up to the leadership of the project is ultimately done by those who contribute. This was a big part of the work that replaced the core team with the Leadership Council. There was very much a feeling that Rust was unintentionally going down the road where you have a divergence between the people who are running a project and the people who are working on a project. And we'd seen a lot of open source projects go that way. We didn't want to lose Rust the same way. And so the rework that created the Leadership Council was an effort to make sure that the leadership of Rust was a representation of the people who worked on Rust. So the Leadership Council has a member from the language team, a member from the library team, a member from the cargo team, a member from the compiler team. All of the individual teams of Rust at the top level have a representative on that and decide the direction of not where the language is going or like where the community is going, because that's still decided by the individual teams, but things that cross many teams. And the Rust Foundation is the legal home for where things that need to have a legal entity live. So things that involve spending money, putting on conferences, owning resources, running servers, that type of thing.
Okay. What are the key differences in how the Rust projects operate compared to other language projects? What can other projects learn from Rust? What can Rust learn from other projects?
So with respect to other language projects in particular, I think that Rust spends a lot of time learning from other languages. We started out as a language that was trying to take the best of both academic research and practical implementation and put them together into something people can use. Add more practicality to really interesting academic research on safety and similar. Add more support and safety to really good practical efforts. And so people took the best of languages like Python and Ruby for productivity, the best of languages like Haskell for type systems and theoretical improvements, and the best of a number of academic research languages, trying to figure out how to put something together that would really satisfy a huge number of people. Rust is striving for that, like, really hard spot of a language where we're not trying to say we're a language for this or we're a language for this. We want to be a language for everything, though. We are a general purpose language the way that C claims to be and C++ claims to be, and like a lot of languages do not aspire to, we are a language for everything. We're particularly good at systems programming. We're particularly good at areas that like C was particularly good at, but we don't limit ourselves to, oh, we're the language for doing AI, or we're the language for doing scripting or similar. And so I think our stability policy is a huge difference between us and a lot of other languages. Very few have the policy of we just never break anything after 1.0 and there's never going to be a Rust 2.0. And I think that plus the addition system, where we have a way of evolving the language and making changes while having projects interoperate, saying this project can link in libraries that are using an older Rust while using the latest Rust features. I haven't seen much like that in many other language contexts, and I think that that's an innovation I'd love to see many other places. Conversely, things we can learn from other projects, I sure do admire the agility of a lot of other languages that move much faster than Rust. And I'm not saying we should move faster, but it sure is impressive to see. And I love learning from the experiments that other languages are trying, whether it is making them a little more user-friendly or making new features that people are particularly demanding. But we're always likely to be not the fastest moving language because we want to be a more secure foundation for people to build on. But we're going to look to a lot of languages to see, hey, here's a fun experiment, and if that pans out, we should try it in Rust.
OK， 我们进入第三个环节啊，从 Rust 的技术细节和设计哲学啊，去了解一下 Rust。那么 next question， well, memory safety and ownership in Rust receive a lot of attention. What underrated Rust future do you think deserve more focus?
So I think there's a couple that I would call attention to there. One is that Rust is incredibly good at concurrent programming. And I think this really passes without notice until you're starting to use it very heavily. That in a lot of languages, the idea of I need to create a new thread and create a message pipeline between that thread and one of my existing ones, that is a non-trivial amount of work. It takes a lot of work to put that together, to get it right, to handle all the details. In Rust, I can be typing away and write like 5 more lines of code, and I have a new asynchronous task or a synchronous thread and a message pipeline between that and the rest of my code, and I move on to doing the next part of the problem I'm solving. And so concurrency is just remarkably easy to the point it almost passes without notice sometimes in Rust. From a more structural point of view, I would absolutely call attention to the addition system again. The fact that every 3 years we can make evolutionary changes in Rust that go beyond an incremental step, that are much larger and allow us to keep the language working as well as possible for people without breaking everybody who's still using 10-year-old stable Rust and counting on it remaining a rock-solid foundation for them. And I think it really goes unsaid that the addition system means people never experience, like, we commonly use Python 3 as an example here, where like Python's an absolutely incredible language. It's great to work with. Python 3 was a really huge problem for the Python community, and all of the users of Python 2 were hit very, very hard by it. And the addition system, I think, is a model for how languages can handle evolution of that magnitude of change without being anywhere near that disruptive.
Okay. Next question. People often say Rust std library is relatively lightweight, unlike the batteries include approach of other languages. Do you think this characterization is accurate? Why has this approach been taken? Do you think it needs to change?
So I think that's a really fair characterization to a point. I think compared to a lot of modern like scripting languages or a lot of other similar languages, Rust includes relatively less in its standard library. We have less than Python or less than Go or less than Ruby, for example. By comparison, people coming from C often tell us that we have a massive standard library that has everything they need in it because they're so used to having absolutely nothing except what they bring with them. So perspective matters a great deal here. But I do think it's a fair comparison that a lot of people miss having certain things in the standard library. And this comes back to that experimentation versus standardization cycle, that we are very slow to add things because we can never take them out again. But sometimes things progress to the point of being a little ridiculous, that until very recently, we didn't even have a plan to add the ability to roll a die or flip a coin in the standard library. There was no random number generation. So if you want to make a game that rolls dice to see how well or how badly you did at something, you had to go pull in a third-party library. And those third-party crates are something that are incredible parts of the Rust ecosystem, but people get frustrated when they need 20 crates to do something relatively basic, and they start worrying about their supply chain. They start worrying about where all of those crates come from, who the maintainers are, whether they're paid well enough to not just disappear one day or get replaced. And so we do try to start adding more things to the standard library, and there's a lot of tension about that. We debate what should and shouldn't be added, but we do slowly and steadily add more things people want. So I had just gotten in a change to add things to the standard library for random number generation. We're talking about adding some more functionality to macros. We're talking about adding a few other things that people look to the top 50 crates in the ecosystem for and can ideally look to the standard library for.
Okay. Next question. How does Rust project decide which features to incorporate into the language itself? Can you share some of the considerations in this discussion making process?
Sure. So this is a part of Rust that I'm really incredibly fond of. The Rust language team is where I first started out and is still the part of Rust that I'm the closest to. And in Rust, anyone can show up and propose a change to the language. It may take time, it may take difficulty, it may take a lot of talking to people and convincing people and incorporating many, many points of view, but anyone can show up and try to make a change to the language. And I know this because I was a random person who knew very little Rust and who wanted to make a change to the language. I showed up, I started talking to people. It took me the better part of a year, and I got a change into the language that people readily use now and is a core part of the language. This took a lot of work, but I didn't have to be a member of a special organization before I could do it. I didn't have to go be in the right closed-door meeting in an international standards organization. I didn't have to know the right person in order to make something happen. I just had to show up and start talking to people and making it work. We have a public RFC process. You write a document that explains what change you want to make, why you should make it, what precedent there is in other languages, what other alternatives there are. You bring that up and talk to people and start making changes. The final version of the change that I made, that very first change, was twice as long and heavily edited from the first version that I wrote and incorporated comments from hundreds and hundreds of people. But it was an open process that everybody could see happen for how that took place. And then within the teams, we have conversations about these. We review them in the language team has a weekly design meeting that looks at all of these possible changes. It looks at particular changes that we're prioritizing and want to make and tries to figure out, is this what we want? Do we want it to be different? Is this the right change for the language? And we move that forward and try to get that accepted through the consensus process.
Okay. Next question. Rust doesn't have a stable ABI. Do you think this was the right decision? What kind of work is happening in this area? What are the main challenges currently faced?
So I do think that this was the right decision in the initial development of Rust, to not have a stable ABI, which means you can't compile code with Rust and then compile other code with a different version of Rust and have them talk to each other, or compile code with Rust and compile code with another language and have them talk to each other without using something other than the default Rust calling convention. You have to use the C interface or some other interface. And this has allowed us to evolve how Rust's functions work very effectively. It's allowed us to evolve the standard library and how it works and not be locked into early design decisions that were ultimately turned out to be mistakes. We made a lot of changes to how Rust calls itself and calls other functions. Now that Rust has evolved very heavily in this area, it may make sense not to necessarily make the default Rust ABI be stable, but to introduce stable ways of making some compromises and saying, I want to make my code callable by 10 future versions of Rust, have it be precompiled and ship it as a binary, and link to that and use it. And it may not have all the features of Rust, but it would have enough to be useful, and we can simultaneously have Rust that with all of its features calling itself, and have interoperability using a large subset of Rust that can interoperate with other versions of Rust, or even with C or Python or Ruby or Go or 1,000 other languages people want to run, and do something a little smarter than the C interface. And the main challenges there are just trying to handle things like the standard library having a particular layout for data structures and not wanting to be locked into that forever. We want to let different things agree on how a hash table works without it agreeing on what exactly it looks like in memory.
OK，时间关系，我们跳过这两个问题，进入下一个环节。You are developing a new build service aimed at significantly improving compilation speed. Could you provide more details about this project and how it will change the workflow for Rust developers?
Sure. I'd love to. So I have cared about build systems for about 2 decades now, and every project I work on, I keep finding myself really wanting particular features of how to build software. You have a piece of software that depends on 100 other things, which each depend on 100 other things, and you want to be able to put that together. And everything I've worked with, like Cargo, is incredibly good, and it's wonderful to work with, and it only works for Rust. And I keep wanting ways to assemble software and ways to put software together that works for any language. And so I started working on that 4 or 5 years ago, trying to turn that into a product. And in the process, I also, Rust is wonderful. Rust has a very powerful compiler. Rust's compiler is a lot faster than it used to be, and it is not known for being the fastest compiler in the world, despite the very incredible efforts of people to make it much, much faster. Thanks, Nick, who's sitting in the front row here. But it is something where some people get frustrated waiting on the compiler to be finished, and I want to make it easy to be doing development on a much smaller, much less powerful device, like a cell phone or a lighter weight laptop, and still get to use 200 cores of a fast system in the cloud to do compilation, but not feel like they have to do the work of pushing it off to the cloud and getting it back. So I'm trying to make it as easy as possible to just run a build that feels completely like it's local and have it take place somewhere else, but it feels still like you did the build locally. And my goal there is to just make it really trivial for everybody, regardless of what resources they have, regardless of if they have like a very thin, light laptop or a cell phone or similar that is, all they happen to have access to, that they have the same development resources that people who have a really powerful workstation have, or a server. So I want to improve access to technology and make people stop waiting on their systems to compile things.
Okay. What are your thoughts on the recently departure of one of the Rust for Linux maintainers? What obstacles does Rust still face in its integration into the Linux kernel?
So that's a great question. I was really sad to see that one of the Rust for Linux developers had finally just burned out dealing with the Linux kernel community and decided that he would rather work on other things. And Rust for Linux is an absolutely incredible project that has tried to bridge the gap between 2 very different cultures, 2 very different development styles, and 2 very different project styles of how things work, and trying to get a safer language into somewhere that is infamously resistant to having safety properties and better, more productive programming mechanisms and similar, and has very much been the staunch advocate of C is good enough for everybody. And I think that a lot of that friction has been a huge number of people in the Linux kernel community have been incredibly happy about Rust for Linux. They're very, very happy to work with it, to help figure out how their part of the kernel works and to help the Rust people figure it out and how to do it. There's a lot of people who are just, okay, that's a thing that's happening in the kernel. I'm not too worried about it. There's a lot of things that happen in the kernel that I'm not too worried about. Architectures I don't care about, or file systems I don't care about, or drivers I don't care about. And Rust is just one of those things. And that was fine too. A lot of people don't have to worry about it. And then I think there's a small number of people who are really afraid of the large change that this potentially represents and worried that, for want of a better description, the knowledge that they have in their head of how everything works will become a little less valuable if it's incredibly easy for everybody to work with and the tools just do a lot of that thinking for you. And so I think that they've coded themselves a very cozy piece of job security, and they didn't particularly want to explain how it worked to other people who want to make it more accessible to people. It's a small minority of people. It is not the primary leadership of the kernel, and the feedback from kernel leadership has very much been, this is an experiment that's happening. It's going to continue happening. It has to meet certain thresholds to succeed, but it seems to be doing well at that, and we're going to keep doing the experiment. So Rust for Linux isn't going anywhere. There are people who are excited about shipping it on all sorts of devices, including people want to ship it on Android phones. People want to ship it on all sorts of devices and firmware and similar. And it's not going anywhere as long as people still care about it.
Okay. Rust is being adopted by more and more companies as its use expands. What changes do you think have occurred in the nature or characteristics of the Rust language? How have these changes influenced the Rust development direction?
I think it's been a really impactful change to see so many companies and individuals really excited about Rust and using it for all sorts of things. I think that Rust really early on was very much like, it was never exactly a hobby project, but it was much, much smaller. And the rate of growth has surprised absolutely everybody, including the people who are closest to it and heavily involved in it. And so as more companies get involved with Rust, as more ship really incredible things built on Rust and build massive businesses that fundamentally depend on Rust, it has created a lot more people who are coming in saying, hey, this is what I need, which has been a certain amount of pressure, but it's also creating a large number of people who really understand how open source development works. And like, we've had shockingly little of the reputation of people showing up and just saying, oh, this is what I need, do it for me, and treating Rust as if it were a company to be directed. We've had a lot more people coming in and saying, hey, I want to build up a reputation within Rust. I want to do work to make Rust better. And by the way, here's some things that would help us out, and I'd like to work on those too. And I think having that level of support has been a wonderful thing. I think that we've had it from so many different companies at so many different directions that no one or 10 of those is, able to drive anything unilaterally. And instead, it's just been a hugely energizing force for people getting supported to, especially, I want to specifically comment about, it's great to have small companies involved because they do a lot of interesting work in unusual experimental areas. It's great to have large companies involved because they have the resources to say, you know what? In addition to the people who are trying to just get their job done and who can't afford to do anything else, here's a bunch of people who are just working on Rust to make Rust better. We'll need it in the next 10 years. And so having both of those around has been really helpful. And a lot of people who are working on Rust are paid by organizations that give them the privilege to say, hey, here's what we think Rust needs. Okay, you should work on that then. That's the kind of job I have. That's the kind of job a lot of my colleagues have is, what do you think Rust needs? Okay, you should do that then. That's what Rust needs then. And then we just work on it. And that's not something you see at every company, but the ones that have been involved doing that have been incredible in making it so that Rust isn't just unpaid volunteers, it's paid volunteers of like, we're still doing what we think needs doing and we make a living doing it. It's been incredible.
OK， 我们进入最后一个问题，歇一下。对，因为时间关系啊，我们进入最后一个问题。Last question. Rust is gaining momentum in China. As a Rust developer, what suggestions or expectations do you have for the development of the Chinese Rust community? How can we encourage more Chinese developers to participate in Rust open source contributions?
So that's a wonderful question to end on. Rust has a reputation, and we're very proud of the reputation of trying to be inclusive to everyone, trying to bring everyone in, trying to raise everyone up, trying to make it possible for anyone to get started. But at the end of the day, we don't know what we don't know. And we will make an effort to find and fix any barriers, any issues that we know about, but we don't know what we don't know, and there are going to be things where we have not realized that it's really hard to contribute in this area if you are, working in China and have certain network access issues for certain resources. We know about some of those. We're working to fix them. We're working to make mirrors of Rust resources in China, or make it possible for local universities and local companies to mirror Rust resources and have those be available to everyone. And there are going to be more things like that, of whether it's communication resources, whether it's communication channels, whether it's our processes and the ways that the project is still, I'll be very clear about this, the project is still very, very heavily dependent on English communication, and we don't have great ways of solving that right now. We need to have much better ways to make it possible to contribute without having English as your primary day-to-day language for getting work done, and we need to make that possible without just having somebody else doing it on your behalf. And I don't know yet how perfectly to solve that, but we need to make it more feasible to have, not just being part of local Rust communities in China, which it's wonderful that those exist, and I'm very happy about that, but also to have people from China and from many places be part of the primary Rust community without feeling like that community is only for people who are from countries that have already been participating or who are primarily speaking English. So that's the biggest takeaway I would say is, we don't know what we don't know. Please tell us if it's broken. Please tell us if there's something that's creating a barrier to joining and participating and working with us. It's like, we are not the type where we're going to react to being told something's broken in Rust with an anger reaction or saying, oh, that's terrible, we don't want to hear about it. We're going to react with that, thank you for telling us. Now we can fix it. Once we know there's a problem, we can start working on it. So if something's broken, call attention to it, file an issue, tell us, reach somebody on a communication channel, anything. And we will try to be receptive to how do we deal with this? How do we fix this? Even if it's a really hard problem, it's something important that we need to work on.
Okay.
I welcome all of the contributions from everybody seeing this and from everybody here in China who cares about Rust and wants to see it bigger and better in the future.
Okay. 非常高兴听到一则消息，就是 Rust 团队在着手解决这个中国的这个 Rust 镜像问题希望 Rust 能在中国就是可以访问非常的通畅。OK， 那么现场我有没有有没有人提问呢？就是可以有2个问题。
Hi, I learned Rust from last May, and currently I build my product on the Rust with the 1.10, and my focus is on the performance engineer. I have a question for you. How you compare the difference between different languages, the performance between different languages? For example, we want to know the give an example. We have a benchmark A that implemented in let's say C or C++ language, and then we implemented in the Rust. How we can compare the performance? Thank you.
So the question is on how you compare the performance of implementations of things in different languages, like an implementation in C or C++ versus an implementation in Rust.
Yeah.
So a few different things. At the end of the day, the best benchmark is whatever workload you're actually using. So whatever you've written the code to do, does it do what you want it to do faster or just as fast using less memory or similar? But there are a lot of tools you can use for that. There are profiling tools that can tell you what the hotspots in your code are if you need to help make it faster. There's tools like Hyperfine, which are really helpful for measuring how long it takes to run your code. There are a number of different tools for measuring what the memory usage of your code is or similar. I think one of the areas that we could stand to do better in Rust is there's some standard answers that people give every time they show up to Rust forums or the Rust Reddit or similar, asking questions about like, how do I make my code perform better or make my binary smaller? And we have standard answers we give, but then those standard answers don't get captured into tools that help you get them right and similar. So the standard problem a lot of people have when benchmarking is, did you remember to compile in release mode? And like, I imagine like you've been working with Rust, that's not going to be the first problem that you have, but a lot of new people who show up writing code in Rust, they're like, why is it so much slower? Like it's a little faster than my Python, but it's not as fast as my C. Oh, you compiled in debug mode. If you compile in release mode, oh, it's so much faster than everything. And those kinds of things are new user traps where we try to catch that. We try to find ways to help the tooling guide you in the right direction, but it's not quite trivial to fall into the pit of success there of like the default is not success, the default is failure. And we need to do better in that of making it easier. So that's the high level on how to benchmark. On some of the bigger details of specifically WebAssembly, we have some experts here in the GOSIM audience. I would say seek out folks like Alex Crichton and others who are experts on WASM time, who do WebAssembly performance day in and day out and could really help with the specific tools for WebAssembly and how to do benchmarking.
Oh, okay. Thank you for your guidance. So basically, you mean there are some tools that can help us to profile a program. But my question is how we can compare the different implementations in different languages, the performance different. So basically, there is no easy way to do right. Is my understanding correct?
I think we should follow up offline about that question. We can talk about it in more detail without the time constraint. But I'd be happy to go through ways of doing better performance for performance testing for WebAssembly in more detail. We should talk.
Thank you.
这下一个问题，还有谁？
Hi, Josh. I'm doing some research work on Rust formal methods or type systems like that. And my question is, how do the Rust community expect researchers can do some contribution to the Rust language? Such as I'm really interested in the placement new or some unmovable structs like the pin API in the Rust and I wonder that as a researcher, how I can do to help the Rust evolve better?
So that's a great question. A while back, it was not as easy for researchers to get involved with Rust. It was less recognized in kind of academics and similar for like how to use this as a research project. And a few early people blazed that trail and made it more feasible and more accepted. And now there are academic departments and journals and papers that have been written and people who have done PhDs and similar, and professors who have a lot of expertise on Rust and how to get involved with research there and how to get that accepted on the academic side of things. On the Rust project side of things, we have, first of all, a lot of interest in having really good academic research on things like type systems and type theory and how to improve the theoretical underpinnings of the language and to advance that further. Like, Rust has always been built on trying to take a lot of that cutting edge academic research and use that to build a better language. So there's two answers I would give. If you have specific things that you want to work on that you're specifically hoping to target, then I would say start a conversation with the Rust language team or with the types team specifically, if that's the area that you're working in, and start mentioning, like, here are some of the areas that I'd like to work in, what kind of interest is in, what interests are there in that, is that something that I might be able to help with, and you can get connected with other people that, we have a few other people who are looking to work in some of those areas, and you may be able to start a conversation there. On a different note, if you're looking to do a research project on Rust and it's less like I want to do this one specific thing and it's more I want to do cutting edge language research using Rust as the vehicle for that, we have several projects that we need to do a better job of documenting, and we should do that. So please do reach out and we can try to do that together. But we have a number of projects that are very much in need of a language researcher figuring out, okay, what would it take to do this? Like, what would it take to do self-referential data structures? What would it take to create a better model for handling memory in Rust without having to deal with pen every time? There are a number of open projects like that that really need some good expertise. I mean, if you really want to lose a decade of your life, try to help us get the specialization system finished. Like, that one's infamous for nobody quite knows how to get it right, but you know, this time for sure, maybe we can get it right. And I'm hoping with the new trait solver that becomes more feasible. So there's a lot of open research projects. If you would like a project like given to you, and if you have a specific project in mind that you want to drive, please start a conversation about it and we can figure out, okay, how does that fit in with the research that we're doing and the things we're trying to add to the language. There's a lot of research opportunities. It's a very rich environment for research in Rust.
Thank you.
OK，
Thank you.
时间关系我们就不再提问了。非常感谢 Josh 的分享。